So we've got our database, we've got our tables, we even got our data types right. We've even got data in there. So how does SQL know what data's in there and how to retrieve it as fast as possible? Welcome back. Today we're going to actually do more of a hands-on training session because we're just going to have a look at all the data that we've actually put into the system, and we're going to have a look at how SQL determines where data is in the world. How does it know to retrieve data from certain data pages and not others, and so on and so on. So for this, we're going to go straight onto the database that we've been creating. I have embellished the database a little bit further. So we're now up to about 750,000 records, and we're going to just have a play around with this particular table. And we're going to go very, very slowly to the big tables. So what I've got is I've created some stored procedures, and we'll go into the anatomy of a stored procedure at a later date. But for now, what I've done is I've got some stored procedures which will get rid of all my indexes. It will get rid of any customized indexes, primary keys, the shebang. So I'll just run that. Also, I want to just make sure that the database is as if it's been switched on for the very first time. Again, we've got to go into all of these areas a bit later on, but suffice to say, for us with our learning steps, this step is to understand how a table retrieves data. So I'm just going to do all of that. Everything is now nice and clean. Over on the left hand side, I've got my table, so I'm just going to refresh these. And we're going to just look at a very small table, which is branch. So at the moment, all I'm going to do is I'm going to expand it to look, and there's only two columns in here, which is the branch ID and the branch name. Now, what I'm going to do is I'm going to just go into a new window, and I'm going to want to inspect this table, which I'm not going to teach you how to suck eggs. We should all know this particular command, which is select star. So give me all columns from this branch table. Now, what I want to pay close attention to is we have all these extra sections on here, and all but one are going to be covered today. And the one in particular I want us to look at to start with is this one here called statistics. Now I'm just going to expand this, and it's blank. Now I'm going to just refresh this and go back in, and it's still blank. Okay, so nothing is there whatsoever. And I would like to think so because I've just cleared everything down. Now, what I'm going to do is I'm going to execute this command. Boom, there's our results. Only 10 records in the entire table. Awesome. Now, has that done anything over here behind the scenes, under the covers, if you will? Now, if I expand that, there's still nothing there. Now, that's because at the moment I'm just doing select star from branch. I am just saying, give me everything. But what happens within SQL is when you start asking questions of your data, like I want to look for specific records, that's when things start to change, because SQL starts learning about your data. So if I now just put in where branch ID equals, let's say, GB, or UK even. Let's do UK. Now, if I execute that and run it, awesome. Now, what's happened over here? Well, if I just now refresh this, I now get something that I didn't have before. What is this? Well, the anatomy of it in regards to the naming convention is quite easily dispelled. The WASys just means it's an automatic system generated statistic. This element here is a unique identifier for the actual table that we're in, which is the branch table. Now, what I can do is if I right click on this and just go into properties, what it does is it actually has now stored some statistics about my table, in particular about the branch ID, because the first time, well, let's put it another way. Have you ever ran a query and it's been very slow the first time, but then when you run it again, it's a bit quicker? Well, there's two parts to this conundrum. The first part is a lot of the data gets cached into memory for the first time. So once it's in memory, it's a lot faster than reading it from disk. But the second and most important one, which a lot of people overlook, is about statistics. Statistics tell SQL Server about your table. What kind of data is inside it in regards how many records, how many A's are there, how many B's are there. It's a little bit more nuanced than that, but at this stage let's just go on the basis of this is the A to Z of the branch ID. Now inside here we have an extra page over here called details. So if we just go into that, what it's doing is it will actually give us, and I'll just make this a bit bigger so we can see it, is it's actually picked up the actual letters of our branches, and there's UK, and it basically starts telling SQL Server what data pages those records exist in. Now that's pretty cool. Now the danger with statistics is that the bigger the table, the bigger the statistics. To a specific point, statistics only take up a certain amount of pages. And at that point, it's got to cram everything about that table in there, because otherwise you basically could be replicating the entire table. So we don't want that. What we want is we need ranges. So if it was numerics, it would be quite easy. If it was 1 million records, you would say 1 to 100,000 is in page 1. 100,001 to 2,000 is in, 200,000 is in page 2, etc., etc. And so what you get is you get a data page full of statistics, which is the lookup reference when you tell SQL to look for something specific. Now, automatic statistics is on by default, but we can turn that off. So I'm just going to close this for a moment and just show you this. And so back in the data and go into properties. If we go into the options section, we've got a plethora of selections that we can do in here. And one of them on here is, oh, would you look at that? Auto create statistics, and it's set to true. So anytime you inspect a column which you don't know anything about, or sorry, SQL doesn't know anything about, what it will do is it will create a statistic for you. Now, this is where the fun comes in when you start looking at performance, because the more records that get added, the more records that get deleted, what you'll end up having is just statistics starting to go out of date. So what we do have is we have this option here, which is auto update statistics. So what it tries to do, and in some cases badly, is it goes, right, okay, I've just deleted 500 records, so therefore I need to update the statistics accordingly to make sure that those particular values are no longer in there if it happens to be on the lower or the upper element of the range. Like if it was A to C and we've deleted all the C's, then statistics needs to be updated because there are no more C's. However, if it was deleting all the B's, then perhaps the statistics don't change. Now, moreover, if you start inserting more and more records into your system, you will get fragmentation, because the pages, remember, are only 8K. And as you hit all the A's and they all fit nicely into that very first page, and then you decide to insert one more record with an A in it, it then has no room. So what it then has to do is fragment the pages. It will add another page in between the two existing so far. So now we've got 3 pages. Now what happens is the statistics also need to be updated to say, right, well, these records now are on new data pages. And bit by bit, time over time, these can get out of date no matter how much also statistics is switched on. So one of the things that you will see later on, and it's not for this video specifically, is you will see where estimates and actuals go completely out of balance because the computer believes there's 50,000 records beginning with the letter A, but in reality there's only 2. Now, and that is a very severe use case, but that could potentially happen. So it's very important to understand that statistics play an immense role in getting your data quickly as possible. Moreover, for those which are more advanced, you've got to consider the fact of indexes. Indexes, a lot of people just start rebuilding indexes immediately. Oh, well, the index is out of date. It needs to be updated every single day or every single week or every single month. Quite often you don't need to change your index. You're more likely needing to update your statistics. So with that in mind, I'm going to leave them switched on because I think having statistics automatically created and updated is a good thing. And that means there's less of you to worry about, but there will be times where you may need to refresh statistics automatically. So I'm just going to cancel that. So what can we see from that? Well, we've now got this statistic within here. If I just go back into properties, we can see it. It's on the branch ID, but we do have the branch name. Now, what I could do is you can create your own statistics. If you're just starting out though, don't. Just leave them alone. 99% of the time you don't have to create a statistic, but you can do it, and it would be foolhardy of me not to say you can do it. So in here I'll just say statistics is called test, and then I can specify what column or columns I want to actually show. So I want, for example, branch name, and at that point what I would do is I would just click onto OK, and then it will generate the statistics for me. There we go, there's test. If I go back into the properties of that, it will have done almost like a select branch name from branch to work out what those ranges are. So if I go in here, we can see Australia, France, Germany, India, all the way to United States. Now, let's do this on a bit of a beefier table. So the first thing I want to do is I'm going to just go and say select start from, let's go to orders. Okay, now orders is a much bigger table. So I'll just let that run and complete. So we've got 158, well, let's call it 159,000 records inside here. So with what I've just done on orders, do I have statistics or anything like that? I will refresh. Let's go down to statistics. There's nothing there. Is there anything in indexes? No. And a little indicator for you is if you have no statistics, you most definitely don't have any indexes. Is there any constraints? Same again, nothing there. It is just a flat table. So let's just see what we've got here. I want to look for a particular order number. So I'm going to say where order num equals 2000. Now, before I execute this, have a think about what is going to happen on SQL, because the more you can start thinking like how SQL works, the quicker you'll be able to derive a lot of problems. You'll be able to sort them out just immediately by just looking at the plan and going, I know exactly what's going on. So in here, we've got orders and we're saying order number 2000. What would we get as a statistic? So let's find out. I'm going to just execute that. There we go. I get 10 records back spanning all the different branches. So the same order numbers in all these different branches. So what's happened on statistics? So let's just refresh this, expand. And there we are. We have a statistic. Let's go into the properties of that. And we can see we've got order num. Now, the interesting thing, well, for me especially, is when you look at the details, because now you can start to see this high and low range I was talking about a little bit earlier on, and it will actually start giving you basically where they actually sit in the world. And so we've got basically our standard statistic. It tells us at the top how many rows were sampled to work out those particular steps. So we've got to just talk about this in a little bit of detail. So what is density? Well, density is all about how much it's sampled to get to that level of density. So you could immediately be forgiven for thinking, right, well, I would want my statistics to tell me where all the Allens of the world are, where all the Barrys of the world are, where all of the Chris's of the world are. It's not the right approach. What we need to do is we need to actually do it in ranges so it can just start hierarchically going into the appropriate data pages, because as we start getting to bigger tables, we have a lot of data pages. So we can't really go straight to a specific data page unless it is an extremely unique record all on its own. So what happens is our sampling is based on how much data is inside here and how much of a gap before I move to the next one. And the easiest way of talking about the density is looking at your high and your low ranges, because at this point it tells you where it starts and where it finishes. So it knows that at this point, these particular values are within these particular data pages. And it gives you the number of rows. So it starts knowing an estimate of how many rows it's going to return. Now we can look at this over here. I'm going to just go back to branch for a moment, and we have this wonderful little one called display estimated execution plan. So when I click onto this, it brings up my results, and when I hover over it, you will see it gives you the estimated number of rows to be read. Now, in this scenario, because it is such a small table, it's actually saying here that the estimate number of rows to be read is going to be 10. But the estimated number of rows for all executions is going to be 1. So why are we getting 10 when technically it knows it's 1? Well, that's because all of the records in branch are in one data page. So 10 records will be read in to get to that one record. So remember that 8K page, all of that data, all of the table references are in that one page. So therefore it's going to read those 10 records in. So what about now with orders? Now it's already got a statistic on here, so it should start understanding where it is in the world. Now, if I just go back into the properties of this, we know we started looking for the value of 2000. So let's have a look in here. Where would 2000 be inside here? So our high range is here to here. It's not that one. It's not that one. Where are we? Could be in this one. So what have we got here? So the estimated row, the number of range rows is that. So let's go run it and see what we get. So we'll just click onto this estimated plan again. And when I hover over it, what do we get? We get the estimated number of executions is 1. The estimated number of rows to be read. Wow, that's a lot of rows. Why? Got to start asking ourselves why. Is it because the number of records can fit into such a small data page? That's definitely not it. Not in this scenario. It's also something to do with what I've got down at the bottom here, which is the convertive implicit going on. However, what I would stress at the moment is that we haven't got any indexes on here. Indexes really define the structure of a table. So at the moment, it's literally having to scan the whole table. But what we can see is it's definitely saying that there's going to be 158,000 rows to be read in. Now, what we can do is we've got another option here, which is to display the actual execution plan. So let's execute that. So there we go. The results came back very quickly, but what's the execution plan say now? Because this will have actuals versus estimate. So the actual number of rows for all executions being returned was 10 records, but to obtain those 10 records, it had to read through 158,000 records. And that again goes back to our statistics range, because at that point it's bundled all that information in, and we will then have the number of rows that are actually being shown inside here, which will be significantly high. So what have we got? We got the distinct range of rows as being 15880. What have we got as our answer? Whoops, let's move that out of the way. Go back to this again. 15880. 829. So pretty close. I'll take it. You're never really going to want to go into that sort of level. This is the sys internals, and there's books that thick on the subject. I am happy to know that the statistic ranges here perhaps may not be to the level that I want, and I may want to make it a little bit more beefier. So we can actually update statistics to be much more in depth, so it's got more ranges possible. But I'm not going to touch that until we get into the realms of indexing, because there really is no point, because at the moment I would never dream of leaving a table without a primary key on it. But what we can see now is we're starting to get statistics on the system. So I'm going to go back into here, and I'm just going to run this bit of code again, which is going to wipe everything. So what we should see now is in the statistics table, my statistics have now gone. If I go back to branch that we did before, there's the 2 statistics I've done. Let's refresh that. My test one's still there because that's user generated, not system generated. So I'm going to delete that one. So there we go. We're now back to scratch. Now what I'm going to do is I'm going to turn on my actual plans. I think it's a good idea for me to turn my statistics on so I can see the number of data pages that are being read. And I'm going to run this first one here. So let's execute that. Tick, 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 tick. It's still executing. And 4, 5, 6, 7, 10. We have to ask ourselves, why is it taking so long? 18 seconds to return. Okay, I know when I'm downstairs on the server itself, it takes about 3.5 seconds to run. But what have we got? We've got select star. So let's just go into messages. And this should be telling us how many data pages have actually been returned. And we can see here that the majority of it is coming from the order details table, and it's taking that long. So let's just have a look at the execution plan, because the execution plan is the roadmap. It's telling us where everything is. So it's looking at the branch table, it's looking at the products table, the users, the orders, and the order details. Okay, so we've done all of that. Will we have statistics on these tables now? Bear in mind, I did select star from branch, and when I ran it the first time, if you recall, there was no statistics. Statistics appeared when I did where branch ID equals UK. So here's a question for you to think about. This is doing multiple joins. It's connecting all the information together. Will it have created statistics? So let's have a look at orders. And we go statistics. Let's just refresh. Do we have any? We do. Now, why? Because you are joining the tables together. So if you're connecting branches to orders and orders to order details and order details to products, SQL's got to know and understand where they all are in the world. And at this point, we're on 18 seconds. I'm curious to know, if I execute that, does it run any quicker? So I'm leaving that running. What I'm going to do is I'm just going to go into here and I'm going to go to the properties of the first statistic that's been created whilst it's working in the background. And you can see we've got branch ID. So what's the next one? We've got the orders. And what else we got? It is created by. So we are going in the orders table, created by, branch, etc., etc. You will notice it came back 1 second quicker. Ooh, it's going to go a lot faster than this shortly. But we can see that because of doing this, it's now started to add these automatic statistics. Now, more importantly, what I'm going to do is I'm going to manually create a primary key. Now, on a primary key is just literally going to make a unique reference for that row. So we change from what's known as a heap, which is one of these, into a proper clustered table. So I'm going to just say create, well, no, I'm not. I'm going to alter table, actually. Alter table, and it's going to be branch. and I'm going to add primary key on, and the uniqueness is going to be branch ID. Right, so let's just run that. There we go. Successful. We just need to refresh the branch table. What we should now have is we should have a primary key. There's our little key icon. Now, because I didn't define a name for the primary key, it's just put in a default one. But if I just go in properties of this, you will see that it's just basically what I've done as the SQL command. Branch ID is now the clustered uniqueness of that table. Now, what about statistics? Do you think there's statistics on a primary key? There sure is. There it is. That one has been named differently. The reason being is it wasn't automatically generated by SQL Server. It's actually created as part of the primary key. If you have a primary key, you must have a statistic. If you don't have a statistic, you can't have a primary key. What about indexes? What if I created a basic index? So create index, and we'll do indexing on a separate video, but I'm going to just call this one test, and it's going to be on the branch table, and it's going to be the branch name. So let's just run that. I've got too many brackets there. There we go, run that. So there we go. So if I go onto indexes and refresh, we'll see there's my test. What about statistics? Let's refresh those. Would you believe it? We now have a statistic. And this is one of the things I was mentioning earlier about some people which are more advanced. They immediately go, I must rebuild my indexes because more records have been added or records have been deleted, and therefore the index is going to get out of sequence. You're right, the index is going out of sequence. But what drives the index is the statistics. So you should be updating statistics first, then indexes. There are specific use cases, especially on primary keys, where you do want to rebuild indexes, but you shouldn't need to do it every single day. Statistics is where you get the performance advantage. So that's that. All I'm going to do is I'm going to go back to this again. Oh yes, I'm going to delete everything and start again. I'm going to get rid of more or less everything that I've done. Now, if we just refresh that, oops, let's go here. We've got the primary key still on there. Let's have a look. Why is that? Because I need to do it manually. So I'm going to just cheat here. I could go and put all the code together, but it's just much easier for me to do that and turn it off and save. There we go. Primary key gone. If I just drop all these again, all being well, I should be in a much fitter state. There you go. All the indexes are gone and all statistics are gone. Let's just go here and make sure it's all gone. Okay. Now I'm going to just jump down a little bit because the first thing to mention is with all orders, what I'm going to do is I'm just going to run this again. And annoyingly, it's going to take 17 seconds. So what I'm trying to do here is I'm going to get these results. I'm going to go into messages. There they are. Now I'm going to go back to that good old web page we dealt with a little bit earlier on, which was called Statistics Parser. And I'm going to run these, put them in, and I can see my logical reads are at 4,297. So I'm going to now run this where I'm going to say I want to look for order dates over a particular area. Now, couple of things. First of all, we've just ran that all orders view. So therefore we now have statistics starting to appear automatically from absolutely everything that has been joined together. This is the first time I'm expressly choosing a column which is outside of those base statistics because it's something in addition on my criteria. So let's just run that. 5, 6, 7, 8. This is a bit interesting. Surely it would be quicker because I'm not looking at the whole table. Well, the clue's in the comment just underneath it. Well, it took 16 seconds, so a shy quicker. You can see I'm now down to 750,000 records, so it's gone down a little, but not a lot. Let's have a look at the messages. I'm going to select Control A, copy. I'm going to duplicate the tab, and I'm just going to now paste these in. Let's have a look. What? 4,297. Let's go back to this again. It's 4,297. What? We've just done a query to potentially reduce it. Hang on. Do we have on the orders table, do we have a statistic on the order date? Let's have a look. Well, we do have 4 automatic statistics. So let's just go into this one at the bottom, the new one. We got created by. What about the one above it? Let's go into properties. What's this? Oh, order date. We've got order date. And when was it updated? Well, it was updated at this point in time at 3:34 p.m. That's precisely the time I ran the query. So it's got that. So maybe it was just a case of it had to create it the first time. Is it going to be quicker than 16 seconds if I run it again? Well, let's find out. Will the pages get smaller? Will I have less to look at? Well, let's find out. So tick tock, tick tock, tick tock. We're already up to 10 seconds and it's still the same. What is happening? 14, 15, and 16. There we go. Exactly the same. So let's go into messages. Has it now got any smaller? Well, spoiler alert, the answer is no. If I just put that back in, I will still be at 4. Click on that. My mouse wheel didn't work. 4,297. So we're still the same as we were before. So what gives? Maybe I just need to narrow it down a little bit. Let's do this. Let's run that. So tick tock, tick tock, tick tock, tick tock. Oh, 3 seconds, 100,000 records. Excellent. So surely my data pages have gone down in size. Let's duplicate the tab. No, they haven't. So we now need to ask ourselves a very important question. What's the point of a statistic if it's just going to look at the whole table? Well, this is where we get into the term called heaps. Tables, when you first create them, are what's known as a heap. They are literally a heap of data. And how the data is stored is it uses an internal numbering mechanism called a RID, a row identification number, to try and maintain consistency and uniqueness. But there's no way of doing that. For example, you can get into a right bit of trouble if you've got 2 fields, first name and last name, and you've not got any IDs on it whatsoever, and you put in 2 Fred blogs or Fred Flintstones. You put in 2 Fred Flintstones, you try and delete one of those Fred Flintstones. Which one is it going to delete? In fact, it's such a good point. Let's do it. So let's just go into a new query. I'm going to create a new table. And inside there, I'm going to have a field called first. I don't care about the data types. And last. Okay, I'm just going to do that. There's our table created. Let's just refresh. So this is something very important about heaps and why you don't want them. So there's our test table. I'm just going to go into edit the top 200, similar to what we did before. And I'm going to put in Fred Flintstone and spell it right would help. And then underneath it, I'm going to put in Barney Rubble. And then I'm going to put in another Fred Flintstone. Making sure case-wise it's exactly the same. But oh, look at that. We now suddenly get a little red marker on this. So what's this going on? So it's telling you you've made a mistake and I've let you do it. So this row was successfully committed to the database, but because it's exactly the same, we may have ourselves a little bit of a problem. So there we go, it's done. So now, if I go into here, well, actually, I'm not going to do it from here. I'm going to do it from here. I'm going to select that. I'm going to just now say, right, delete. Do you want to delete that? Oh dear. What's happened? Well, it's saying I've got a bit of a problem now because I've got 2 rows which are identical and I can't delete one of them. And that's because there's no real uniqueness about these columns. And I've had this with clients where they've got a log file and they've just been populating things. And at a certain point, we get the same entry multiple times. And then you try and delete them, becomes problematic. You must have a unique identifier on your table to allow this to work. So how do we get out of this pickle? Well, the easiest way of getting out of this pickle is by creating a unique identifier. So I'm going to go into the design of the table and I'm just going to put in ID, leave as an int. And as we talked about on our previous video, I'm going to just put in the identity specification of 1, but I'm also going to make it the primary key. Now that way then it's belt and braces. I've just told SQL Server there's now a unique record to this. So if I just rerun this, I'll need to, let's just close it and go back in again. So let's just go into edit top 200 rows. There it is now. So now if I come to delete Fred, when I hit delete, I'm not deleting the words Fred and Flintstone. I'm deleting the row ID of 1. And that is a unique reference and the reason why you need primary keys. And now think about what we've just done in the terms of statistics. If I have 2 Fred Flintstones, what page are they on? It hasn't got a clue. It could be on page 1 and page 20 because you've got 2 Fred Flintstones. Well, if I've got 50,000 Fred Flintstones and 1 Barney Rubble, well, that's very similar. It's going to be a situation is it's not going to know where everything sits. So it's vital for primary keys to exist. And a primary key is a unique identifier which actually clusters the data and puts it into those pages so it knows exactly where it is in the world. Without primary keys, you will never have a performance system because everything about a primary key drives your statistics, drives your other indexes. It puts things into order from chaos. So as we talked about back in this one, we've got some really bad searching going on because unfortunately with this one that we just ran here, if we go down to the orders table, which is where the order date is, we hover over it. The poor old computer didn't know what to do. So the actual number of rows read was 158,000 records, but it only wanted to return 20,161 records where the order date was greater than May the 1st. Now, the other records get whittled down even further when we start looking at the branches. When the branches start coming in, it will narrow it down even further still. But what it's effectively doing is it's having to scan, even though we've got a statistic on here. You can see the statistic is in play. We've already seen it over here. But it really doesn't matter at this stage if we don't have a semblance of order, which is your primary keys. So let's just go and create our good indexes. So these are all the primary keys. So boom, that's done. Now what I'm going to do is I'm going to run this again. Let's execute it. So we're back in 3 seconds. We've got the same number of records, but what's actually going on behind the scenes? Well, let's go to messages first. And what I want to do is I want to see how many data pages have now been returned. So let's just duplicate the tab. Go into here and paste. And we're now down to 601 pages from, just a reminder, 4,297. Now this is still bad for what's going on. We can narrow it down further by putting on better indexes. However, now we've got those indexes, the statistics involved are a lot better because the statistics now know where the data pages are and all the Fred Flintstones of the world will potentially be next to each other if it was indexed on them. So now if we go down to here and have a look at orders, we'll see that if you look now, the actual number of rows read isn't 150,000 like we saw a moment ago. It's now 21,000. And why? Because the index can work in conjunction with our statistics. The statistic ranges have been changed thanks to the primary key. So instead of them just being higgledy-piggledy anywhere on the data pages have been realigned to fit in with our index. And that is why we need primary keys. This is not a video about indexing, that comes in later, but it's vital to understand what a primary key is and its impact with statistics. Statistics are the driving force for us to pinpoint the records, and without them, you're going to be scanning forever. So hopefully today's video has been of some use. Let me know in the comments below any questions you may have. This is not the last time we will be dealing with statistics, but it's a pretty good opening gambit in this realm, is that you do your select and your where clause, but there's an awful lot of stuff which goes on underneath. Thanks for watching, and I'll see you on the next one.